Hey everyone, Mr. Kimsing here. Sorry I couldn't be there in person, but hopefully be back in action pretty soon. Enough about me, but you are starting a new topic this term, and technically this is an advanced topic. But as Extension 1 students, you guys will be extending that knowledge and actually looking at a lot more complex kind of operations of what we call polynomials. But just for reference, this is from the advanced exercises, so just so you're aware. Anyway, let's jump into it. So essentially, what I've got here is something that seems quite unrelated together, but actually share a common theme. So on the right, you've got some shapes, and we refer to these in a mathematical term as polygons, right? So poly means many, and on the left-hand side, I'm not sure if you recognize it, I used to play with these all the time. They're like packaging peanuts, and not actual peanuts, I'm allergic to those, but packaging ones. And I think, you have to correct me if any chemistry students out there, but these are made of polystyrene. And essentially, again, this idea of poly means many. So to my understanding, it's made of a few different kind of chemical components and sort of mashed together to create this kind of synthetic material, right? And so this idea of what we call polynomial is the same thing. We're looking at many somethings. We're looking at many nomials. We're essentially looking at many terms, right? Here's a bit of a definition for you. A polynomial is a function, and we've looked at that before, defined for all real x involving non-negative powers of x. So that's really important. It has to be non-negative powers. We've got a few examples below that we want to look at. So it says, which of the following are polynomial expressions? And you can see there, 3x squared minus x. Remember, x is just x to the power 1 essentially, plus 4. And what's plus 4? Well, I guess you could think about that as if you wanted to, x to the power 0. But we don't really need to write that, right? So this first one satisfies the definition for polynomial expression, which is good. And we know that that's actually a quadratic. We've seen that before as well. And so that's also, not only is it a function, it's also a polynomial, right? What about this next one? X cubed minus x squared plus x plus 5. Same idea, it meets those conditions. It doesn't matter what powers you have or what numbers you have or what coefficients there are. It's as long as it meets that criteria of non-negative powers of x, it's a polynomial. And we know that this one is a cubic. Right? Same thing with the next one, meets the criteria. Any guesses what this one's called? This one is a quartic. We're very creative with our namings. Next one, though, is a little bit different because it's got x to the power negative 1 there, right? And so x to the power negative 1, we know, and that's another way of writing 1 on x. And so it is a negative power. So that one we actually don't consider to be a polynomial, okay? Some of these you might not have seen before, but we can actually have what we call exponential functions and even trigonometric functions. Now, because they are not involving powers of x, or non-negative powers of x, these are not considered polynomials either. They may be functions, but they're not considered what we call polynomials. There's a strict definition there. And also, it doesn't really matter what order you put them in. You can mix them around. We know that addition, subtraction, doesn't matter what order we have them in, as long as we've got that definition of above, and this is considered this one's a quintic, looks like polynomial, right? And now I've included this kind of like formal mathematical definition, only because it is referenced in your textbook, and also it's good to know the sort of general terms. So if you sort of think back to those binomial expansions, it's a similar idea that it looks really intimidating at first, what's in the box. But essentially, when you break it down, it's just saying any polynomial should follow this format. So the degree is the highest power in the polynomial, so that would be n in this case, right? So n minus 1, the powers get smaller and smaller. Just note though, they may not always write in order. Sometimes they're a little bit tricky. And we look up above. Some of them are in order in terms of like descending, but that last one wasn't. So it's always the highest power that you've got, that's the degree. A sub n x to the power n. So that's kind of, if you look at this first term here, right, that would be the first term. It's the leading term. So that's the one with the highest power. And that should be a sub n actually, sorry. So a sub n is the leading coefficient. So the number that's attached to that. So in these cases here, it looks like they're all actually 1, which is not super exciting, is it? So those ones there are the leading term and the leading coefficient. The number at the end, we call that the constant term. And in these cases here, when the leading term or the leading coefficient is 1, we call this a monic polynomial. So monic is just 1, right? So if the leading coefficient is just 1, we call that a monic polynomial, right? Those are just a few definitions there that you've got. And so for these ones, you can identify the degree, the leading term, the leading coefficient, and constant term of these ones here. So I'll work through the first one with you, and then you can try the next one yourself as well. Let's get a bit more space going on here. Oh. Okay, so the degree for this one, so this one would be a degree 6, because that's the highest one that's there. The leading term, so that's the whole thing here, so that's the leading term, that would be leading term x to the power 6. The leading coefficient though, if you think about it, remember, so if it's just a 1 in front, that's how we can think about it. So the leading coefficient for this one is going to be 1. And the constant term, just the number at the end. Remember, it's the whole number that's there, so the constant term would be negative 3. So constant term is negative 3. Okay, so that's the first one, part 1. Try the next one for me. See how you go. Okay, so pause the video. Hopefully you've had a go at it. Now for this one, same idea. The degree, so the highest power that's there. So this one's a degree 5 polynomial. The leading term would be the whole thing that's there. So the leading term is going to be, looks like minus 3x to the power 5. The leading coefficient, again, this one, just look at the coefficient of that term. So the leading coefficient is just negative 3. And also constant term. So constant term is going to be, looks like 5. Okay. Now, with these ones here, just think about, all right, this first one, that was what we call a monic polynomial. This is a monic polynomial. And that's because the leading coefficient, this one was 1. This one here isn't. It's a non-monic polynomial because you've got a negative 3 as the leading coefficient there. Okay, so just watch out for that.